All right, so this is 10.3. Well, actually, that's the pretty good. It's on cross products. Okay, so cross products are not the same as dot products, so that's important. With cross products, you're still in a three-dimensional plane. We're going to say we have two three-dimensional vectors. So 10.2, if you've not watched the video, it's on three-dimensional vectors. And I'll go over questions if you have them on the homeworks as soon as we finish these notes. But we're going to say U is this vector U1i plus U2j plus U3k. And vector V, we'll call it V1i plus V1j plus V3k. So what we're going to do is we're going to create a matrix. And some of you hopefully know what a matrix is. Yes. Not the movie, but the actual,
I've heard it's bad and it's only hyped because it was like the very first movie with CG.
And we bought a DVD player because of that movie. That's the reason we bought a DVD
awful.
player. The Matrix?
Yeah, I don't think it looks interesting.
Oh, I've watched them all, but that was, like I said, during the 90s.
Are the eyes like imaginary or
Not imaginary, those are like X, Y, Z, I, J, K. So this would be your X component for the vector, your Y component for the vector, and your Z component for the vector. So the three dimensions, the third dimension is the Z. Remember in the video I talked about going X, Y, and then the Z goes up. I talked a little bit about isometric drawing paper. Remember that?
Today's Tuesday.
It's literal Tuesday.
Yeah.
Okay, so what we're going to do a cross product is we're going to create what I'm going to call the ijk vector. Let me fix that I, that's a terrible I. J, K. And then what you do is you take the numbers from the U vector and from the V vector and you put them in here. So we have U1, U2, and U3. And then the V vector will go below it, V1, V2, V3. We're going to do something called a determinant. Now, how many of you know what a determinant is for a matrix? We will be doing a lot of determinants in the next chapter. Okay, this is just kind of an intro into a determinant, and that is going to be our cross product. So U cross V is going to be this. Are you ready? Okay. I'm going to write it down, but it's not going to make a whole lot of sense just yet because we don't have any numbers, right? When we actually put numbers in the places of the U's and V's, it'll make more sense to you, hopefully, and be kind of simple. So here we go. We're going to take the I column and row out. So see how I put the I in front? This is called expansion method. We're taking one matrix and we're going to expand it into three smaller matrices. So take out the column the I is in and take out the row the I is in. See that? What's left? These four numbers right here. Technically letters right now, right? You see that? Okay. So you're going to write these four letters in your matrix. So V2, V2, U3, U2, U3, V2, V3. I can't even read my own letters. I shouldn't just use these because they look too much alike. But anyway, U2, U3, V2, V3. Now, the next vector is J, the J vector, or matrix, I guess. But, you see I put a minus? Why did I put a minus? Because I had to. When you expand matrices using the expansion method, you have to follow the sign pattern. It's plus, minus, plus, minus, plus, minus. It has to go back and forth, always. So if you start in the upper left, which I did, it's a plus, then a minus j, and then it's going to be a plus j. Okay, so it's always going to be a minus j. And what matrix do we get if we take out the middle column and the top row? We get the U1 and the U3, right? And the V1 and the V3. So U1, U3, V1, V3. And then see if you can write your own K matrix. Take out the K column, what do you get? Write it down. I'm going to put the answer up here and see if you wrote the correct thing down. So if you take out the K column, you have U1, U2, and V1, V2. Is that what you wrote?
Mm-hmm.
Okay, so we're pretty much done, except we have to realize that this is still a vector, right? You know when you do a dot product, you just get a number? You like have a number plus another number plus another number. It's two vectors dotted together gives you a scalar. Do you remember that? No, you don't remember that. Okay, when you dot product, you do a dot product, you get a single digit, or not just, it could be like a 10, but one number. When you do a cross product, look what we got. We still got an I, a J, and a K. So you still get another vector. Now what do you do with these matrices? You just leave them as matrices? No. What you do is called a determinant. We're still doing a determinant. You do left diagonal minus the right diagonal. That's the determinant of a 2 by 2 matrix. So we're going to do left diagonal. I say left diagonal because it starts at the top left. So it'd be U2, V3, U2, V3, minus U3, V2. So it's the right diagonal. It's always a minus. What would this number be here? Again, you're going to do left diagonal minus right diagonal. So it's going to be this times this. U1V3 minus U3V1.
Do you still have like the I and the J and stuff?
Yeah, those would still be there. I could show you some of my grad class problems where I had to do cross products all the time. Sometimes with calculus in them. Lovely. Yeah. Left diagonal here is U1V2 minus U2V1. Now I think it looks kind of confusing with all the U's and V's, don't you agree? But when we put numbers in, you'll see how simple it really is. Okay? We're just going to do one basic example. We're going to apply it to all the different things that you would use cross products for. Any questions about this before I move on? These numbers here? Yeah. You take, I call it left diagonal because it starts at the upper left. You go this way, you multiply, and then you subtract this way. You do like U1, V2, and then you do subtraction, U2, V1. It'll help if we actually put numbers in, I think. So it'll make more sense. Okay. Let me do the example and why do cross products? So let's figure that out. So I'm gonna give you two vectors in 3 dimensions. It's okay. Everything's okay. It'll be fine.
It's your model for life.
Yep.
You sound like Dory.
I just watched that movie.
Keep us Miami.
She did, not you.
Oh. One thing I did notice about Screencast-O-Matic versus just me recording the Google Meet, Screencast-O-Matic seems to pick up on every little sound more so even than the Google Meet recording.
Great. That's just wonderful.
In calculus, I had a couple people that here that were like talking, and you could almost hear their conversation better than me talking in the front of the room. It was weird. Okay, here we go. We're going to do our IDK vectors, or matrix. These are vectors. We're going to put our U and our V columns in. 2, 4, 3, -1, 3, -2. Okay, now we're going to do our cross products. U cross V by expanding the matrix. So again, we're going to take the I in front. We're going to take out the I column. We're going to put down the numbers that don't have the I in them. So it's going to be these 4 numbers here. Okay? So these are the 4 numbers we're going to write down. 4, 3, 3, negative 2. Minus j. Again, it's always a minus j. That's how the expansion works. If we take out the j column in the middle, what do we have?
2, 3, negative 1.
2, 3, negative 1, negative 2. And the k. Take out the k column, we have 2, 4, negative 1, 3. Why did it pause? Or no, maybe that's from before. Is it still recording?
Yeah, it says recording.
Okay. Just making sure. All right, now we're going to do that thing that I just talked about with the left diagonal minus the right diagonal. Remember that? With using these, it was kind of confusing. But with the numbers in the problem, it should make more sense, hopefully. Hopefully. So let's start with this I matrix. We have the left diagonal, which is 4 times negative 2. What's 4 times negative 2? Negative 8. Minus the right diagonal. What's 3 times 3? 9. So what's negative 8 minus 9? Negative 17. So we have for our I portion of the vector, it's negative 17I. We're going to do that again for the J and the K matrices. So we have, again, left diagonal minus right diagonal. The left diagonal will be negative 4. Be careful when you do minus and negative, of course, because that tends to be where people mess up. We have minus a negative 3, so it's plus 3. Okay, so that's negative 1, but I also have a negative j. So it's going to end up being plus j. And last but not least, the K matrix. So the left diagonal here is 6. The right diagonal is a negative 4, so it's going to end up being a plus 4. So my answer for my cross product is this matrix, right? Or that vector right there. Now, what is the purpose of a cross product? Well, in 3 dimensions, you have 2 vectors going whichever way in 3-dimensional space, right? The cross product of those 2 vectors is a third vector that is perpendicular to both of the vectors given. You can check it by doing a dot product. Do you remember what it means to get a dot product equal to 0? Perpendicular. So if I check this vector with either one of these, let's just do it real quick. Negative 17 times 2. 1 times 4. 10 times 3. What do I get for my dot product? So if you check the dot product, you get 0. Let's check this one with the second one. You should get 0 again. Negative 17 times negative 1. 1 times 3.
So if it doesn't equal
10.
0, then it's wrong?
Yes. So my dot products are 0 for both. That means it's perpendicular to both of them. That is a cross product. So sometimes it will say, find a vector orthogonal. That's an O. To the given vectors. That's what we did. So the instructions might not say do a cross product. It might say find a vector orthogonal to the given vectors. That means do the cross product. Okay? There's another thing you might have on your homework. It might be like find a unit vector. To find a unit vector, you have to take your vector and you have to divide by its magnitude. So we're going to take this vector and we're going to divide by the square root of what? Remember how to find the magnitude of a vector? We just did it in 10.2. And we also did it in
S squared plus y squared plus z squared.
Yeah, and when you type that into WebAssign, it wants you to use v sub 1 squared, like v sub 2. You have to use the subscripts that it gives you. You can't use x squared, y squared, z squared. Just so you know. That's number 2. or 3 on the homework from 10.2. All right, so I'm gonna do 289.